This will be for the Kuta software worksheet, trigonometric ratios. All right, so just some notes before we begin. These functions, sine, cosine, and tangent, these are actually the ratios of the side lengths in a right triangle. Okay, so the way you remember these formulas is to remember the phrase or acronym SO, CA, TOA. Okay, the S stands for sine. On the calculator, it's SIN, written SIN. The C stands for cosine, written COS. And the T stands for tangent, written TAN. Okay, so you'll see sine, cosine, and tangent on your calculator. All right, and as far as the other letters, the O stands for opposite, the A stands for adjacent, and the H stands for hypotenuse. All right, so we'll be labeling these three sides on the triangles on the worksheet in a moment. Anyhow, like I said, this is pronounced sine, this is pronounced cosine, this is pronounced tangent. And this basically tells you the formula. Oh, and one more thing. This symbol right here, okay, right here, that represents the angle. And it's pronounced theta, okay? It's a Greek letter, theta. It represents the angle. So for this formula, the sine of theta equals opposite divided by hypotenuse. The cosine of theta equals adjacent divided by hypotenuse. And the tangent of theta equals opposite divided by adjacent. All right. So like I said, the O, the A, and the H are opposite, adjacent, and hypotenuse. These will be the sides of the right triangles. All right. And theta is the angle. And you just remember SO, CA, TOA to remember these formulas. All right, let's start with number 3. And we're taking the sine of the angle C. Okay, so basically, C is the angle. All right, because we're taking the sine of C. The first step is to go to that angle and label the side. So let's go to angle C on the triangle, which is right here. All right. So this is angle C, and you go angle to side. You go across from angle C, and that side length right there is considered your opposite. All right, I'll just write OPP. The hypotenuse is always across from the right angle. So again, go angle to side. That right there is your hypotenuse. I will abbreviate HYP. And finally, the third or last remaining side, which in this case is 21, is going to be your adjacent. So I'll just label that ADJ. All right. So the first step is to label the sides. You go to the angle that's given. Across from that is your opposite. Across from the right angle is your hypotenuse, and the remaining side is the adjacent. All right. And now we want to see which trig function we're using here. We're using sine. All right. So if you remember the phrase, SO, CA, TOA. The one for sine is the one with the S. Okay, this is the one for sine. So that's the one we're going to be using. All right, so this right here tells us that the sine of an angle theta is going to equal opposite divided by hypotenuse. So that's the formula we're going to use. All right, and we're looking for the sine of C. So in place of the Greek letter, the angle theta, I'm going to put in the C. And that's going to equal opposite, which is 28, divided by hypotenuse, which is 35. All right. Now, the way to reduce a fraction is to divide the top and bottom by the same number. Okay. 28, and you want to basically try to pick the greatest common factor. 28 and 35 are both divisible by 7. All right. You want to divide by the same number on the top and bottom. 28 divided by 7 is 4. 35 divided by 7 is 5. And 4/5 is your final answer. All right, please pause and try number 2 in the same fashion. Remember to label the sides first, but in this case, you want to use the formula for cosine. All right, so we're taking the cosine of the angle C. So go to angle C, go across from angle C to the side, angle to side, and that side is going to be your opposite. Go across from the right angle to the side, and that side length is your hypotenuse. The remaining side, the one that's left over, is going to be your adjacent. All right, so once again, so katoa. All right, you don't necessarily have to write this every time. But since we're using cosine, the C here represents the cosine, so we're using that one. All right, in this formula, cosine of an angle theta equals adjacent divided by hypotenuse. In this case, we're doing the cosine of C. That equals adjacent, which is 16, divided by the hypotenuse, which is 34. Okay, these are both even numbers, so I'm going to start by dividing by 2. Make sure you do the same number on the top and bottom. 16 divided by 2 is 8. 34 divided by 2 is 17. 17 is a prime number. So that is the fraction in reduced form. All right, please pause and try number 10. All right, the first step, as always, is to label these sides. All right, we're taking the tan of the angle C. So we're going to go right to angle C, which is right here. Go across from angle to side. That side length is your opposite. All right, I'll just write OPP. Across from your right angle is always the hypotenuse. And the side that's left over is your adjacent. All right, in this case, we're using tan. So once again, so katoa. All right, this is something really you could just think in your head. You don't have to write it every time, unless you just want to write the one that you're using. Okay, in this case, we're using tan, so use the one with the T. We're using toa. So tan of the angle theta is going to be opposite over adjacent. All right, tan of theta is going to be tan of C. Opposite is 27. Adjacent in the denominator is 36. Reducing that fraction, the greatest common factor, I believe that's going to be 9. So I'm going to divide top and bottom by 9. All right, 27 divided by 9 is 3. 36 divided by 9 is 4. That's your final answer. If you divide by a number that's too small, you may have to divide again and reduce it further. All right, in the next section, it is basically the same process, okay, but this time instead of reducing fractions, we're going to round to the nearest 10,000th, okay? So that is 4 decimals. All right, so for this section, you're going to need the calculator. All right, like I said, it is still the same process. All right, so right here, we're looking to find the tangent of angle A. All right, so A is the angle. And just like we've been doing, you go to angle A on the triangle, that's right here. All right, you go across from the angle that's being referenced, and that side length is your opposite. For the hypotenuse, you look for the right angle. You go across from angle to side. That side length is your hypotenuse. The remaining side that's left over is your adjacent. All right, and we're looking for the formula or for the tan function. All right, so remember SO, COT, TOA. All right, we're using TOA because the T stands for the tan function. All right, so TOA means that the tan of an angle theta is going to equal opposite divided by adjacent. O divided by A. All right, so we're doing the tan of angle A. So in place of the Greek letter theta, write the angle A. Opposite is O, that's 21. Adjacent is 20. And you want to go to the calculator. We're just going to do 21 divided by 20. All right, here's Google's calculator. 21 divided by 20. And hit equals. And I get 1.05. All right, if it was more decimals, you would round off to 4 decimal places. But for this one, you don't have to. It's 1.05. All right, so for this one, there was no round off. It was just 1.05 for the final answer. All right, so everything is the same, except at the end, you have to round off. Or at the end, you have to use the calculator and possibly round off. All right, let's try number 21 together. And what you want to do is use a calculator and make sure the calculator is set to degrees. Okay, it should have a menu on your calculator to set it to DEG for degrees. All right, so we're doing the cosine of 61 degrees. This, of course, the 61 degrees is the angle or angle measurement. All right, so let's go to the calculator and round off. All right, most calculators, you type the cosine first. Some of them, you type the angle first. But you want to make sure you're set to degrees. All right, so the one in blue in this calculator, the one in blue is what you're using. And we're doing the cosine of 61, close parentheses, okay? Cosine on your calculator is COS. This angle is in parentheses. And let's see here. All right, so remember that we're rounding off to 4 decimal places. So 1, 2, 3, 4. You look at the fifth decimal place. If it's less than 5, you round it down. In other words, you just leave it as is. So it's 0.4848. If this number right here was 5 or more, you would have rounded it up to 0.4849. If this one was 5 or more, okay? But that's not the case here. So since the fifth decimal was less than 5, you just keep it as is, 0.4848. All right, so number 21 is approximately 0.4848. All right, if you want to put a 0 in front, that's fine, but it doesn't change anything. And why did I use squiggly lines instead of an equal sign? Well, the squiggly lines means that you rounded off. Okay, so it means approximately.